All right, so let's start. With questions. So here's the what we're doing today. I did start the screencast. First, I'll have questions. Then I'll give you an update on the website, and then some reminders, and then we'll talk about Python, namely how to make functions, how to return multiple arguments from a function, or sort of do that in a very eloquent way, and how to put code in files, and also how to create your own classes, the basics of that. So let's start with questions.
Not quite sure how to do question 4.
Okay. You mean the one you want to solve for tonight? Or grade?
The solve one, the fact
Okay.
one. Oh, yeah. Copy the file.
Okay, so you want to know some hints about that would be useful. So let's see. Basically, there's a module OS and another module shutil, and there's just a few functions there that you'll use. So, but I said that in the hint. So I'm trying to think what I should do. How did you get stuck, or why were you stuck?
Can you start like how to import statements?
Okay. So, let's see. So I'll show you a few basic examples of using those things. How's that? All right, so they're actually already, or some of them are imported, but let's do import os.listdir. And then what you do is you give a directory as input. Dot stands for the current directory. And then what it'll do is it gives you back a list of the files in that directory. So that's how you get all the files in a directory in your Sage Math Cloud project. That's how. At least if it's the current directory. If you want to go into another directory, like one level up, you could do ... That'll give you that one, etc. So when you use this, it's relative to the place where your file is, where your worksheet is as a file, and lister will give you a list of all the files. It's just a list of strings. Okay? And then another command that's relevant to that one is, let's see. So there's a few things you might want to do with shutil. So you do import shutil, and then that gives you a module called shutil. And if you want to find out all about that module, you can type, well, there's two things you can do. If you want to stay completely in a worksheet, you can just type help and the name of the module, and you'll get a whole bunch of output which describes the module. Alternatively, for almost any module you can think of, if you type Python space module name into your favorite search engine, then you'll get the official Python documentation on that module. However, you may have to watch out because it might be the Python 3.4 version of the documentation rather than the Python 2.7 version of the documentation. So that's, it won't make too much of a difference with this module, but it could with others. If you type help, though, you're going to get exactly the version that's included in this version of Sage. So there it is. It looks like it tells you about the module. It has lots of documentation. Also, in addition to doing help, you could just type shutil.tab, and you'll get a list of all of the functions that are defined in that module, all the things in there that you might call. And there's lots of useful things like copy file, copy tree. I think there's a remove file somewhere, or maybe not actually. There's a remove tree. For deleting a file, there's something else you do. So tab key. For removing a file, it's os.unlink, as it turns out. That removes a file. Okay, so your specific question was, how do you import stuff in the context of that problem? Do you have another specific question about the problem? Yes? No, for that problem, you can completely ignore the file permissions. Okay, and in general, the I guess, extended attributes of the file are not necessary. Yes?
Are we supposed to assume the second directory is
It's ambiguous in the question, isn't it? I'll show you how, obviously it would be better to write something that doesn't assume the second directory exists. And I'll show you what the commands are that you would use to write such a thing. There's a command, just deleted all that help. There's a command os.makeDirs, and if you give it a path, it will make that directory. So that makes a directory. And now if we do os.lister, say on the current directory, it will show that foobar is now there. The annoying thing though is you have to be careful because if you call this and you already called it, then the directory exists and you'll get an error. So you need to first check if the directory exists before you call this by doing some if statement. Alternatively, and we haven't got to this yet, you could use exception handling and put a try except around this. I'll illustrate that though, in case you want to use it. You could do the following. What you do is so if you do this, whoops, that's invalid syntax, sorry. If you do try colon and then give a collection of commands indented, and then say except colon, if an error occurs anywhere in the evaluation of those commands, then the code that's after except, that gets evaluated instead, or at that point. In particular, it allows you to try something, and if there's an error, you can ignore the error completely, other than having your function crash. I'll say a lot more about try except probably on Monday. Yes?
Do we assume the destination exists?
You may specify clearly either that you will or will not assume it in your solution. I think a better solution would certainly not assume that the destination exists, because it'd be better to create the destination if it doesn't exist, but it's up to you to decide which way you're going to go, okay? Just be clear that you either do or do not assume that the destination exists. Okay? Any other questions about that question? So like when you're programming, there's kind of like, there's all this stuff that's very much just kind of math and manipulating data structures in memory. That's like one kind of world of programming, which you can solve a lot of problems with. Then there's the programming that involves manipulating all the files and sort of data on your computer. That's external. It involves a lot of operating system calls, like making a directory, reading the contents of a file, copying the file, etc. And so that's another thing. And then there's another level of programming which involves the network, the internet, basically, where you send you make TCP connections to some other computer, and you send data, and you get data back. And there are like 3 different levels of the scope of what your program is working with. And this problem takes you beyond the just purely working in memory scope to actually looking at the file system. But it's really important to be able to do that if you're going to do anything at all non-trivial. Like, for example, save your answers beyond just copying and pasting something out of here. Okay? Okay, further questions? So a reminder, which I'm sure all of you know, the homework and the grading of the other homework are both due tonight at 6 p.m. So finish the problem we were just talking about, and then also your grading by 6 p.m. tonight. And then sometime after 6 p.m. I will automatically collect everything and then redistribute it just like before. But fortunately this time you'll only have to grade 3 because there are 40 people in the class rather than 39.
Are you going to take the whole directory again for the homework?
Yes.
Okay.
Yeah. I'm always going to take the complete copy of your homework, and I'm keeping all of those the whole time in a separate location just in case. So yeah. And then that's what I'll be spreading out again to everybody else. Okay. Other questions? Oh, okay, so status update. So I made a enormous amount. I pushed out some changes that I spent most of the time during the last 3 months writing to Sage Math Cloud, and there were a couple of projects that temporarily suddenly had no files at all, and then add files back again. So if that happened to you and it caused trouble, make sure to let me know so that I can fix it. I think all projects are fixed now. It was about 150 of 46,000 that I think got messed up. But basically, the files were there, but in the database, there's a pointer to where the files are, and it was pointing to the wrong location or nowhere at all. Because in the migration process, something went wrong. So that happened with a few of them. If this caused enormous problems for you, let me know, and I will extend the deadline right here. If you had trouble specifically because of that. Okay. Also, so with projects, you might note that with some projects, let me go out of here for a second. So in the new version, there's now additional information about things like disk space and RAM, and stops after a certain amount of inactivity. So if a project isn't used for a certain amount of time, then it will stop running. But I just held the 9 key down and made a very large number and set that for all the projects in this class. So the upshot of that is that in most cases, your project will open very quickly and it will stay running even if you're not touching it for a day or two, which is nice. Otherwise, the default is they'll time out after 3 hours. So I just set it to essentially infinite for this class. Okay. But let me know if you see anything really funny as a result of this update. But one thing is it should feel a lot snappier. There's a lot of reasons for that. But it's kind of like, well, basically before there were about 5 different things that were all simultaneously slowing stuff down a lot, and they're all kind of stripped away. So it's a lot sleeker behind the scenes. Like before, SSH was being used to tunnel kind of a lot of different connections, and that's all removed. And it's just a lot faster. And there's just a lot of things that are far more efficient. So it should feel snappier and better. Okay, so let's see, that was that. Anything else to say about this? I think I just said everything that's here. All right, so let's move on to functions. So first, there's a few subtleties to Python functions and a few neat things you can do with them. Let me make this a little bigger so it's clear. So we've already seen multiple times that you can define a function like this. You give a valid identifier, like foo, and then you give some variable names with possibly some default inputs. Remember we did this a bunch at the end last time, and I pointed out some subtleties with default inputs, which I won't go into at all today. And then inside of here you can, do all kinds of stuff. Like that, for example. Now if I do foo of 5, just 5, it should return 20 and print something out. So there's 2 things that happened here. Foo of 5 returned 20. So the expression foo of 5 evaluates to 20, and that's why the 20 got printed out. But in the course of doing that, it also printed out A is true. So that's what happened. And so you could have alternatively just assigned to a variable like that. Now z is equal to the result of that evaluation, which is 20. So that's the quick review, and then there's doc strings and so on. But you guys have done this a lot now. So let's see. Now I'm going to tell you about a few more advanced things related to defining functions. Okay, one, you can define functions within functions. You can nest them. So let's say that you want to do that. You could do this def g of c returns c times c. And then here you could do, now you can use that g right here. But you can't use g anywhere outside of this function. It's completely local to that function. This should print out 400, I think. But if I try to call g out here, it should just give me a big red error because I haven't defined g outside. So inside of a function, you can define lots of other functions, and they're completely local to that function. And you can even define a function and a function and a function and a function. ... I don't actually know how deep that goes. Never looked. That might be a fun thing to try to figure out. Okay, so there's that. You can do neat things with functions. So let's do another one where we create a function and return it. Multiplier n. So what we're going to do is make a function that takes as input a number or something and multiplies it by n. Okay? Oops, that's kind of useless. But now we'll put return f. So now the cool thing is if we do multiplier, tab completion works here, say 17 m. Now I give back something that is a function itself, which when you apply it, when you call it with some value, it multiplies that value by 17. So look, if I do m of, I don't know, 3, I'll get back 3 times 17, 51. So you can make a function that constructs a new function and returns that, and then you use that for something else. Yes?
So when is it more efficient to return a function rather than just define it outside the original?
Well, then it's not so much about efficiency as flexibility. Because when you define a function at the global scope, it's just kind of a once and for all thing. Whereas here, you can make a function that's sort of much more flexible in what it does than if you define it at the global scope. Like if you just want to make something multiplied by 17, always, then you can define that at the global scope. What if you want to make something that multiplies by the value of some number in a file that you're going to read in? And this could be a good way to do it, something like that. So it provides a different kind of flexibility than you might otherwise have. So that's one topic. Basically, functions are they're things that you can pass around just like any other Python objects. That's the point here. And you can even take a function itself, say m in this case, and do m.tab, and there's various methods and data attached to a function. For example, if we were to add a doc string in up here, this is a doc string, and then evaluate it, which is easy to forget to do. Then if you do m.tab func doc, oops, sorry, not m, but multiplier func doc, it'll actually give you back the string that's the doc string. And you can even set this. Say you want to set the doc string dynamically after you define the function. You just set that equal to a string, and now the doc string is that. So Python is very, very dynamic. You define stuff, you can look at what the documentation is from the code, you can change it dynamically as you're going. It's extremely dynamic, which makes it powerful, a little terrifying, and not necessarily fast in some cases, i.e. potentially very slow in some cases, because it's really hard to make a language that's this dynamic very fast in the sense of low-level number crunching. You really need to call functions that you import from some other library, or you have to use Python to do low-level number crunching. But one of the things that Python makes it easy to do is to take code that's written in another language like C, just like a huge library, for example, written in C, and then call it directly from Python. And you get the speed of the C code with the flexibility of Python. Okay, so let's see, there's that. Now another standard topic is variable number of arguments. Okay, so this is something that most languages have some way of doing this, but here's an example. I think if we do that, I hope. Nope, that doesn't work. Wouldn't it be nice though if we had a product function where we could literally just give a whole bunch of inputs as separate inputs to the function and it would multiply them all together? It'd be kind of nice in some cases, right? Let's see if we can figure out how to do that. So what I've shown you so far, there's no way to do that. Because when you define a function now, like the way I've shown you, you have to explicitly say it takes 2 arguments or it takes 3 arguments. And that's it. That's your only option with what I've shown you. But it is possible. There's a notation in Python, pretty clean and simple, that lets you define a function that takes any number of arguments. Okay? And here it is. So I'll define a function that allows us to do the above. So I'll call it myprod. And what you do is you put an asterisk before some variable name. People typically call it args, but you don't have to. It's just any identifier at all. And now, here's what will happen. I'm just going to make this really simple first before we make it do what we really want. if you plug in some arguments, what it does is it takes all of those arguments and puts them together in a tuple, which is, tuples are, again, very similar to lists, except you can't append to them or anything. They're like unchangeable lists. It just puts them all together in a tuple and gives you that tuple as that variable, named as that variable. Okay? So it's kind of an advanced idea, but it works, and it's not too complicated. The notation's pretty clean. So here's the challenge. How do we make this actually give us back the product of all of the inputs? So what will we do? What code are we going to write? Product on what?
Well, because ours is a tuple.
You're right. So we can probably just feed that tuple into prod. So I'll just write return prod of args. And what that'll do is it'll take prod, which takes a list or a tuple, I hope, as input, and multiplies them all together and it'll work. Okay, so let's try it out. I'm going to get rid of that silly why hell. I don't know why that's there. Some random thing. And this should be 60. Unless, of course, prod doesn't take tuples, but that would be stupid. Okay, 60. And there it is.
Was it just a fluke that it took that long to evaluate?
It didn't really take that long to evaluate, but the worksheet didn't get synchronized quickly enough. And I hit the save button to force it to synchronize ASAP. So that caused it to synchronize again. It should never do that, but it does sometimes. And it's a place that is ripe for optimization. So that's it, though. That's how it works. Pretty simple. So if you want to make a function that can take in a whole bunch of different arguments, or you don't have to specify ahead of time what they are, then you can use star args. And you can also throw in some named arguments at the beginning before the asterisk, like a comma b, like that. If you do that, then args is only set to the rest of the arguments. So if we evaluate that, and then this, 3 and 4 are going to be a and b, and then star args sucks up the rest of the arguments, and star args sucks up the rest of the arguments, and then that's all that gets multiplied together. The 3 and the 4 aren't included in that product. Okay, and you can also do a variable number of keyword arguments. The notation is very similar. You just put star kwds. And now what will happen after I evaluate this is that anytime we give some keyword arguments like, I don't know, xyz equals 56, abc equals hi, then those will get put into keywords, not as a tuple, because there's no notion of order, but as a dictionary. kwds, or whatever variable name you want to call it, gets set equal to a dictionary with all of the keyword arguments to the function. So not only can you specify a variable number of positional arguments with star args, you can also specify an arbitrary collection of additional keyword arguments with kwds. And then there's one other thing with variable numbers of arguments, and that's passing them back into another function. So if I do args equals, and I give a tuple, like that, and I do keywords, and I give some sort of dictionary, this, that. Now, here's how I call my prod. So the positional arguments, well, I just say star args and star keywords. And I can also give some positional arguments at the beginning if I want. So what this will do is it lets you take and create a dictionary very dynamically in any way you want. And then if you call a function and put 2 asterisks in front of that dictionary, it's exactly like if you were to put key equals value into the function. So it makes it incredibly flexible as far as figuring out what the inputs are to a function that you might call later on. You can just create dictionaries, make tuples, and then put an asterisk or a double asterisk in front of them, and it's as if it's exactly identical if you would put 7, 5, 6, 8 in as positional arguments, and this equals the string that as a argument there. Okay? And now that's everything about positional and variable number of arguments in Python. Yes?
Can you have two different sets of arguments?
Nope. You have to, it's exactly like this, and it has to be first star args, and then second star keywords. You can't suddenly have more star args or more star keywords. This is all you can do. And if you think about it carefully, anything else would be ambiguous. So it's the only thing that isn't ambiguous. Okay? Yes?
Pass it like to two people, but it's not going to be a single one assigned to ours.
It passes in two tuples. So notice I put the asterisk in front. But if even if I put like a tuple of two tuples, or I didn't quite understand your question. Say it again.
If you didn't define args, you just gave several tuples to my pod, would that flatten them and put them together into args?
No. It would literally make args equal to
Several tuples.
a tuple of tuples. And then of course it would break because prod doesn't take tuples as a So yeah, that won't work. It won't just flatten stuff. Okay, so let's see. Okay, the next topic involving functions is returning multiple values. Okay, so the short answer is, and this is the case with most, I think, programming languages, a function can, so in Python, a function always returns exactly one thing. That's it. You can't return multiple values. But there is a convention that makes it look like you are, and it's extremely eloquent. So short answer, not don't, but can't. But here's what you can do. This will look, for the moment, like I'm returning multiple arguments, but then I'll explain to you that it's actually just a clever, eloquent little trick of Python notation. So let's say we define a function powers that takes as input a number n. We want to memorize the powers of a number, do something with them. And we want to return the first few powers of n as separate things. So we'll return n squared, n cubed, and n to the fourth. Okay, and I'll do powers of, I don't know, 5. So what happened there? It kind of returned 3 things. And here's another thing you do: a, b, and c equals powers of 5. And then like if you print out a, well, let's do print a equals b equals c equals. So you cannot return multiple arguments, but it really looks a lot like I did just return multiple arguments, if you look at what just happened here. So I defined the function around line 140. On line 141, I said return, and I gave 3 separate expressions that should get evaluated and returned. And then when I called it, I ended up getting back a 3 tuple, which is, of course, one single Python object. But down here, what I did is I said, let's let a, comma b, comma c equal powers of 5. So it actually equals that 3 tuple. And let's print out what a, b, and c are. And separately, those 3 different variables are equal to 25, 125, and 625. So right here around line 147, it looks a lot like I returned 3 values, right? But it's all an illusion. In fact, what happens is the following. If you So there's 2 things. One, if you have 3 identifiers, or any number of identifiers, and you make a tuple with them in it, and you set that equal to another tuple, it assigns them position by position. But also, if you just leave out the parentheses in Python, it makes a tuple anyways. And so it's just a funny Python notation that allows you to do this sort of thing called tuple unpacking. And at the top, it's also tuple packing, because if you give a collection of things separated by commas, and you don't bother with the parentheses, Python just puts them together into a tuple. So it makes a tuple, and then this assignment unpacks the tuple. That is, it gets the 3 values out of the tuple and assigns them to those variables. This is hopefully pretty readable, I think. So it's an eloquent solution to a problem that comes up a lot, especially in math, where you want to return multiple things from a function. And you want to do that in a clean way. In Magma, which is another language that has a lot of clever constructions, you can define a function and make it return multiple things, but it's really weird how it works. If you leave off, say, some number of these, the behavior of the function can be different. It actually knows how many values are being expected as the output and will adjust its behavior accordingly, which is pretty disturbing. Also, that's just confusing potentially. And then another issue is, like, what happens if you say x equals powers of 5? What do you think that's going to do? Here, at least. It's not going to be a big problem. We think of powers of 5 as returning 3 values up here, but if you say x equals powers of 5, what is x going to be equal to afterwards? Exactly, it's just that 3 tuple. No problem. Even though, so if we, it just sort of works very naturally. And it even works nicely for iterating. So let's see. Okay, so here's an example. If we take powers of 2, powers of 3, powers of 5, powers of 7. So we get a couple of 3 tuples. Whoops. Uh-oh, what is wrong? Generic power takes at least 2 positional arguments. Oh, look at that. Thank you. Okay, and now you can do things like for a comma b comma c in V, print, I don't know, a plus b plus c. So that's really eloquent as well, I think. If you have a list of tuples or any iteratable thing that gives you back 3 tuples, then you can say for a comma b comma c in that thing, and it'll go through one by one, giving you back that object, but setting a equal to the first thing, b equal to the second thing, c equal to the third thing. So that's really, really nice and clean. This is just giving us the sums of each of these. 4 plus 8 plus 16 should be 28, etc. Okay? And you'll see this sort of idiom used constantly in Python. It is a nice, clean, pretty idiom without really any major gotchas that I can think of. And I probably could think of some if there were any. Okay? Any questions? Yes?
So you said for A and B, A would be equal to the tuple, right?
Yeah, if you said for A and B, then each time you went through, or as you went through this, it would set A equal to the tuple, etc.
So what if you had for A comma B and B?
That is a great question. So first, I'm going to illustrate the answer I just gave. This should give us back a bunch of tuples, and it does. And your question is, what if I do for A, B, and V? I think that's your question.
Yeah.
Okay, anybody have any bets about what's going to happen? What do you wish would happen?
First 2 values.
Just the fact that you aren't confident about what should happen should be a tip that probably it should be an error. And I think it's going to be an error. I really hope it's an error. It's an error. So what's happening here is it's unpacking a 3 tuple, but you've only given it 2 variables, A and B. So instead of just throwing away the third one, it gives you an error. That's very kind of the way Python would do things. If there's not a clean, unambiguous interpretation of your notation, at least of your syntax, then it will typically just raise an exception. This is the exact opposite of, for example, JavaScript, which, if it had something like this, would undoubtedly be perfectly happy with it and just throw away the last value and do what you guys expected. Like with JavaScript, where if you use a variable you haven't defined, it's suddenly undefined by default. So there are very, very different approaches. But this is a pretty reasonable approach. Okay, so it's an error. But you can use the len function, len, to figure out whether an unpack is going to work or not. By the way, there are many different error messages like this. And here it says value error. There's lots and lots, there's dozens and dozens of different exceptions like this. And using the try except thing that I showed you, you can catch them so whenever they happen, you can do something else that you specifically decide on. So that can be handy in practice. Okay, so that completes talking about defining functions. Okay. All right, next I'm going to show you how to put code in files, which, I don't know, I think I will show you, I'm going to show you an email so that if you feel confused, you'll feel that you're not alone. So here's an email from a few days ago from one of the world's top number theorists at Imperial College London, where he's like, okay, I wrote some code. This is really tiny. Let me make it bigger. I'm bewildered. So Kevin wrote some code in probably a notebook or on the command line, and then he was like, oh, this should be in a file. What should I do? And he started Googling randomly and probably found something about Python and files. And he put it in a file called test.py, and he just put exactly the code he used in Sage in the file test.py, and it totally didn't work at all, and he ended with being completely bewildered. So this could easily happen to you, except it's not going to happen to you because I'm going to explain to you all the subtleties which would have made it so he would not have been bewildered right now, okay? It only takes like 5 or 10 minutes. All right, so the idea here is we have a little bit of code and we want to use it in different worksheets, say, or you want to take the code and put it on a cluster somewhere and run it on a whole bunch of computers, or I don't know, you just want to do something with it. You want to share it with other people, and you don't want to specifically have it in one particular worksheet or something like that. Okay, pretty standard thing to want to do. If you've taken a programming course, you probably wrote all of your code that way, where it was in various files, and then you loaded them or compiled them or something like that. So I'll show you how to do that sort of thing in this Sage Math Cloud, but the steps we're doing are identical however you're using Sage and Sage, basically. Okay, so let's make a .sage file. So we'll make a program that will be in another file, and it'll have a little bit of code in it. So we'll define some functions and so on, and then we'll load it, and we'll have access to that code. Okay, that's the goal initially. So first we'll make a new file by clicking on New, or however you make a file on your computer. I'll call it test.sage. And then I don't click on Sage Worksheet. I don't click on IPython Notebook. I click on Create File. And then boom, I now have a nice, clean, new file. And I'm going to define a function in it, which I'll call, actually, how about the myprod function? I'll just copy and paste that over, because I really liked myprod. Maybe clean it up slightly. So at this point, I mean, it's just standard writing, Sage code. But let's just make a little thing. I'll give it a doc string. This is myprod in another file. Not a very good doc string. And then it will return the product. Okay, and then we just save the file. And now let's go back to the worksheet and go anywhere we want. Say right here. And I'm going to type %load test.sage. Woohoo! So what I claim happened was my prod got loaded from that file. And I'll verify that by typing something in and noting that it worked. And also, we could do myprod ? And we'll see that the doc string is what I just wrote. This is myprod in another file. So shouldn't seem that exciting, but the point of this is that you can put like pages of code in test.sage, type %load, and then the name of the file, and it all gets loaded in. And it could also be not just defining functions. You could put any arbitrary code in here. Like you might want to do some sort of setup, like my data equals n squared for n in range 10. So that'll be defined after you load the file. So go back over here, type %load test.sage, and then not only will it define that function, but it will define my data, which should now be defined. Not m data, but my data. And indeed, there it is. Okay, so this is a way of putting a bunch of code somewhere that all the code is interpreted very similarly to how it's interpreted in the notebook. except that you don't have most of the percent things, but which are often special to working in a cell, like percent time and so on. But it's a good way to just write a bunch of code. And you can run it in other ways. So for example, let's say we want to have access to my data and this function, myprod, but in the command line. So you can go to the command line. You have to be in the same directory. But here we are. Make this really, really, really ridiculously big. You could type Sage. It will start up Sage. And then you could say, and this is annoying, but you have to say run file rather than load due to some arguments that I lost. And there you are. Okay, so you have it here as well. And you can, well, anyways, so there's that. A second thing you can do, which is similar to this, is you can write Python programs. So let's do something similar. Oh no. Well, hopefully, that's terrifying. It's recording the video and it's about to run out of disk space. Maybe I can delete the video from last time. Yeah, I'll delete the one from last week, which is already uploaded, I hope. Okay. All right, so let's make a file test2.py, for example, test2.py. By the way, don't call it test-2 or put a space in the file name. The name of the file has to be a valid identifier, just like a Python variable. So you can't put like a minus sign in it or something, which is something would be very nice to be able to do, but you just can't in Python. Okay, so we create the file. And now this is pure Python code. So for example, if I try just doing exactly what I did here, this is going to fail in so many different ways, it isn't even funny. So, and this is, of course, what Kevin did wrong. He didn't realize that. So test.2.py, this is just pure Python code, and we can bring it into our Sage session or the Sage command line or whatever by saying import test2. And what that does, it'll take each thing that's defined in here and make it available under the test2 namespace. However, all of that happens as pure Python. There's no pre-parser at all. And so, for example, that caret right there will be interpreted as exclusive OR. And the prod, you don't have any of the functions that come with Sage. You just have what's included in pure Python. You have to explicitly import prod from somewhere if you want to use it. So I will illustrate the utter and complete failure of this now. So let's try to import test2. This should fail in many ways. Actually, it'll probably import fine. It just won't work. Okay, that's all right. There's one other thing. Python has a load path, so it's like a list of directories where it looks for files to import, and apparently the directory in which we're working is not included in that path. So there's a workaround, which is os.path.append. I think dot will do it. Wait, oh, it's sys.path.append. Okay, there. All right, I think I should change it so that's always appended to sys.path, but okay. I'll put a comment here. So we can import Python code in current directory. Okay, it's now imported. So it imports fine. And it's just like any other Python module. You can do module name.tab, and you see the functions and data and whatever is defined in there. It's really nice because it has its own namespace. That is, it's everything that you just defined by importing this is available under test2.tab. It's like it has its own scope, which is really good. But there's some annoying things just because it's not pre-parsed. So for example, this is not the powers. It's exclusive OR of these numbers. Because caret just means something different in pure Python. And then also the myprod is going to fail. It'll fail because there's no prod function at all. Global name prod is not defined. So you could do this, and there's hundreds and hundreds of thousands of lines of code that defines Sage itself that's written in Python files like that, or Python, or similarly Python files. And the vast majority of, there's probably like 50,000 Python libraries at least out there that you could just get. there's a package repository called PyPy, which has enormous amounts of Python code. And it's, of course, written mainly in these .py files. They're all packaged up. For completeness, though, let me show you how to fix this so that it works as expected. So first, let's import prod. So everything in Sage is in this this module called sage.all. So if I do from sage.all import prod, that imports the prod function from sage.all as the thing. So now prod is available. And also in pure Python, instead of a caret, we use double star. By the way, if you wanted to figure that out from within Sage, there's a command preparse, which it takes any Sage code and turns it into the corresponding pure Python code. So if I take this line right here, and I go right here, and I type preparse of it, then it will give me back what Sage does to this line before feeding it to Python. And then I could use that over here. Okay, so now we'll save this file, and now we'll try running it again, or actually, we'll try importing it again, and amazingly enough, this is not going to work. And I'll explain why in a second, or rather, what to do about it. Okay, notice it's just as broken. Well, maybe slightly less broken, but it's still pretty broken. Import happens once. Once it's done, it assumes that the file is not changing and will not import it further. That's just how Python is defined to do things. However, there's another command, very similar to import, which will reload a file once it's already been imported. And that command is called reload. So watch. Finally, if I do reload test2, okay, that's good. So what happened is that integer isn't defined, even though I used it explicitly here. So now I can change that. And then go back here. And now finally, when I reload it, it'll work. And moreover, if I try these tests above, they're going to actually work now. So I'll copy and paste them down here, and then try them out.